feeling groovy. That's what we're feeling today. So I want to welcome you to the Johnson Kendro Video Hour.
But it's not an hour.
All right, gonna figure that out one of these days. All right, quadratic formula. It's a formula we use in quadratics. Okay, normally we remember solving quadratic equations, we used it factoring. We took out big, the numbers they have in common, and then we factored it into two parentheses and solved each of those. But what if it can't be factored? What if the numbers don't work? Well, some genius back in the ancient times figured out this formula to be able to solve for the quadratic that isn't solvable.
That's pretty scary looking.
Yeah, well, it's not difficult to use though.
Okay.
All right. So we got to remember our A's and B's and C's. Okay, that comes from right here. A, B, and C. Those just get plugged in right into the formula. And then all you have to do is work it out. All right, so here are the hints. Make sure you have it in standard form. That's the form up above. Use parentheses because the negatives will really mess you up. Work under the square root first, and then take the square root. Then you want to add or subtract those numbers. And then at the end, you can divide by the 2a.
Using heart surgery.
Yay, heart surgery. All right, here we go. So, this is our A.
Wait a minute, you don't have standard form.
Oh my goodness, I don't. I was getting ahead of the game here. I'm so excited to use that quadratic formula. All right, so I'm going to subtract 2 from both sides and get it in standard form. 3x squared minus 5x minus 2 equals 0.
Good job.
Okay. Now, if I want to, I can try to factor that into the two parentheses, but I'm going to find out that it doesn't work. It just doesn't, the numbers don't work out. So I'm going to take, this is A, this is B, and this is C. So, let's put that in our formula. Negative B is positive 5. Plus or minus, then we have B squared is 25, minus 4 times A, which is 3, times C is negative 2, and then put it over 2A.
I like how you made your fraction bar big enough to cover everything.
Yeah, because if you only put it under the radical, it's going to mess you up. That 5 won't know what it's supposed to do. All right, so now we're going to work under the radical. I'm going to leave everything else the same. And 25 minus, now 4 times 3 is 12, times 2 is 24, but minus a negative is actually going to be plus. So I have 25 plus 24, I think that's 49. And then 2 times 3 on the bottom is 6.
Okay.
All right, so now I do know the square root of 49. Do you?
7!
Woo! So I have 5 plus or minus 7 over 6. Now this is actually two answers. One is 5 plus 7 over 6. The other is 5 minus 7 over 6. 5 plus 7 is 12 over 6, so that's 2. So x equals 2, and the other one is 5 minus 7. That's negative 2 over 6 would be negative 1/3.
Oh, so two answers.
Yep.
Okay.
All right, let's look at this next one.
So something special we're going to find out about this one. All right. Again, it's not in standard form, so we need to make sure that it gets there. And I want positive a's, so I'm moving the 2x squared to the other side. That'll give us 2x squared plus 4x plus 3, and I'm going to throw my 0 on this end because I'm used to that. A, B, and C. Plugging it into the formula, opposite of B, so we'll say negative 4 plus or minus the square root of B squared, so that's going to give me 16 minus 4 times A times C, and then it's going to all be divided by 2 times A.
I see you're using the parentheses correctly. That's
Thank you.
Nice job there.
Thank you. Then we have negative 4 plus or minus, leaving everything the same, working underneath the radical. Mrs. Kendro talked about this. Just treat this like negative 4 times 2, which is negative 8, times 3 is going to be negative 24. And kind of to check yourself, if you have an odd number of negatives, it should stay negative. If you ever get an even number of negatives, they should be a plus in there. All over, I can probably do this at the same time, get a 4. Negative 4 plus or minus. Now if I take 16 and I subtract 24,
I don't think you can get a negative because the numbers you multiply together have to be the same.
Right. So
to get a negative, you have to have one of each.
So for us to get a negative, this actually is going to have an imaginary solution.
Imagine that.
And we don't know anything about
Oh my
imaginary
gosh,
numbers yet.
that looks too freaky. We're not doing that yet.
So when this happens to you in your quadratic formula lesson, what you are going to say is that there is no real solution. And the reason that this happened, you don't know until you get a negative underneath the square root.
Okay, so negative on the square root, we just write no real solution.
Yep. Let's try one more of those. And this is not necessarily a no real solutions. It's already in standard form. The A is actually 1, B is 4, C is negative 3. Plug it in. X equals opposite of B plus or minus the square root of B squared. So 16 again, minus 4 times A times C, all divided by 2 times A. Work underneath the radical first. 16. And then I have an even number of negatives. That means it's going to be a plus. So I have 4 times 1, that's 4, times 3 will get a 12. All divided by 2. Next, add those two things together. We get negative 4 plus or minus the square root of 28, all divided by 2. So this isn't a no solution problem, and we're not done yet. I haven't boxed it in quite yet. But what I do notice is that I do not know the square root of 28. And for us to get this solution, we would have to continue going at this point with decimals, and we don't want decimals. Those are not exact answers. So what we're going to have to do is simplify that. And we're going to talk more about this a little bit later, but I'm going to give you the short version. You want to split 28 into factors that are perfect squares. So perfect squares are like 4 and 9 and 16 and things like that. And 4 is a factor of 28. 4 times what is 28?
7.
So 4 and 7. Do you know the square root of 4?
I do.
What is it?
2.
2 root 7. So to simplify this, I'm going to leave everything else the same, and I'm going to do 2 root 7 instead of root 28. And Mrs.
Heart
Kendall
surgery.
has a really smart trick here. What she's going to do, if you have a common factor, see my pretty red heart?
It's beautiful.
Thank you. Mr. Tiano taught me well. They're all divisible by 2. So you can go back and divide them by 2, not inside the radical though. And that would leave a 1 on the bottom, but remember you don't need the 1. So the final answer is this. We do not want decimals. We're going to keep it exact.
All right, and the plus or minus we can leave in the middle as a shortcut, right?
Right.
We don't have to write them separate.
Right. Technically this represents 2 solutions. At this point, you know, if you guys were to leave your answers like that, it's not the best, but it is still accurate.
Right. Just try to simplify it all the way down.
Okay, the discriminant. The discriminant is kind of a fancy word for, it's basically a test that we can run to figure out how many solutions and what kind of solutions our quadratics have. So if you notice the 3 examples that we did, there was something that changed that determined what kind of answers we got, and it was what was under the radical. So that's the b squared minus 4ac part of quadratic formula. And when we got different things, we got different answers. So I'm going to give you a little table here to help you categorize your answer. So what we will do is simplify the b squared minus 4ac. And if you get a positive answer, what that means is you have, oops, I deleted my words, 2 real solutions. It means that your parabola does cross the graph twice, okay, at 2 different places. If you were to ever get a discriminant value that is equal to 0, I don't know where my words are going, equal to 0, that's kind of a unique situation. What happens then is you have 1 real solution, and that means that the vertex of your parabola is right on the x-axis. So what's left?
That's the one that came out negative.
That's right. So if you get negative numbers underneath, we already talked about what you will say. They're imaginary solutions. That's because those parabolas don't cross. Okay, their solutions are imaginary numbers.
Oh, imaginary, though, is something we'll talk about later.
Right. So here's how these problems look. They just will say, evaluate the discriminant because we want to know how many and what kind of solutions our problems have. So my A is 1, my B is 6, my C is 9. And remember, the discriminant is just B squared minus 4AC. So we'll plug them in. B squared is 36 minus 4 times 1 times 9. 36, that's going to be minus 36, which is
0.
So you look back at your chart. 0 means one real solution.
Now, make sure you put real, because sooner or later we're going to be talking imaginaries.
Yep. I'll just do one more and then we can skip the last one.
All right.
All right, here's our A again is 1, our B is 6, and our C is 8. B squared minus 4AC. So this time I have 6 squared minus 4 times 1 times 8. That is 36 minus 32. Now the answer is 4, but we need to use the categories. 4 is positive. Therefore, 2 real solutions.
All right. Nice work.
Okay, last example. Take it away, Kendro.
All right, we're selling tie-dye shirts. Look at those cool cats over there. Profit depends on the amount of X that they charge for each shirt. All right, give us an equation, and it models the profit. We want to know what's the least amount of profit. Okay, I'm going to underline that because I got to remember that for later on. They can charge to make a profit of $100.
So what's the least amount that we can sell the shirts for to earn $100?
Yeah, very good.
Okay.
So first thing we're going to do is substitute the profit in there. So for P, we're going to put 100. So into that equation right there, we're going to put 100. Then we have negative x squared plus 48x minus 300. Next step, get it in standard form. That means I got to have 0 on the other side. I want to bring this stuff over here to make the positive x squared. So I'm going to add x squared, I'm going to subtract 48x, and I'm going to add 300.
Ooh, you're doing that all at once.
Yeah,
That's very fancy.
got talent. So, if I think about doing that all on this side, I've got x squared minus 48x, and then I have 100 plus 300. That will give me 400. Yes. All right, and then it's equal to 0. The next thing is use your quadratic function, to solve.
Quadratic formula.
So I'm going to put that in a different color. I'm going to write it down real quick. Plus or minus b squared minus 4ac all over 2a. So the opposite of b is 48 plus or minus b squared.
48 squared
is 2304. All right, and then 4 times a times c, that's 400 times, or 4 times 400 times 1, which is 1600. And then
divided
by 2 times 1, which is just 2. Okay, keep going here. 48 plus or minus. Under the radical, 2304 minus 1600 is 704. And divide that by 2. Now, 704 is not a perfect square. So we are going to have to use decimals, but this is a real-life situation where we're talking money. So decimals are okay with money.
Okay, so don't leave it as root 704.
Right.
Okay.
Because somebody looking at that in the store is going to go, how much does this cost? You got to go, money is money. All right, so square root of 704 I figured out to be 2653. And now I have to do my 2 separate equations here. So 48 plus 2653 divided by 2. If you work all that out, you get 3727. Okay, so that's 37.27.
Now we got to do our subtraction.
Right, so 48 minus 26.53 divided by 2. Work that out on your calculator, you get $10.74. Except
we wanted to know the
least amount they can charge. All right, so you got to be careful with that one. The least amount they can charge would obviously be the $10.74. They'll still make good profit. Yeehaw! All right, see you in class. Ta-ta!